Well, hello, my name is Mrs. Welch, and I'm going to be helping you guys through the notes for drawing conclusions and proofs this chapter. Before we get into the drawing conclusions, I want to draw your attention to these 2 pages in your packet. They're going to be super helpful if you, actually, I would recommend that you bookmark them in your pages so that you can find them really easily under the bookmark section of Notability, because this is where all of your definitions and theorems are going to be. You'll notice that I went through each of my definitions and I highlighted the key word in the hypothesis and the key word in the conclusion for each of these, just to let them jump out at me, because the hypothesis is now going to be our given information in each of our problems, and our job is to find the conclusion. So finding those keywords and the given and the hypothesis is going to make our job a lot easier as we draw conclusions today. All right, so now we're going to see how we're going to use those definitions with our geometry problems. So first thing I want you to notice, like I said before, the hypothesis of the definitions and theorems that we're going to use is going to be given to us in the given information. So whatever keyword that you see in the given information is the hypothesis of the definition. So for example, in number 1, it says segment FM bisects segment DR. When we look up above, we look at bisect here, and bisect says that if a segment is bisected, then it divides the segment into 2 congruent parts. The first part, the hypothesis, is the given, and so we can conclude that there's going to be congruent parts that we can find. So let's see what happens here. FM is bisecting DR. So DR is being cut by FM. So FM, if they're the scissors, I even sometimes, to help me remember what the order here, FM is cutting DR into 2 congruent parts. So if FM are the scissors, then that means DS and SR are the 2 congruent parts. So we can say segment DS is congruent to SR because that big segment DR is being cut in half. It's being cut into 2 congruent parts. Okay, again, we named that, we could make that conclusion based on the definition of bisect. Number 2, the given information is that these 2 segments are perpendicular. So we think of the definition of perpendicular, and then we look at the diagram. These 2 segments are the ones that are perpendicular, and we know if segments are perpendicular, then they form right angles. So where's the right angle in our diagram? Oops, it is right here. So we can say angle FDM is a right angle because those 2 highlighted segments are perpendicular. That's the conclusion we can make based off that given information. Number 3, ray FM bisects angle DFR. So again, because of that word bisect, we know that if something is being bisected, it's being cut into 2 congruent parts. That's the conclusion we can make. So we find angle DFR. This ray is bisecting that angle. So it's dividing the angle into 2 congruent parts. So we can say angle DFM is congruent to angle RFM because the angle is being divided into 2 congruent parts. That's what the definition tells us. All right, number 4 says that these 2 segments are congruent, so the conclusion is there must be a midpoint somewhere. If we look at the diagram, if segment DS is congruent to segment RS, well then this point in the middle of them should be the midpoint. So we can say S is the midpoint. All right, you try number 5 on your own. If these 2 angles are congruent, can you name the angle bisector? So can you conclude what the angle bisector is? Try that one on your own. All right, so in the diagram, the blue is what we were given. The pink is what we can conclude. We can say ray DS, starting at D, heading towards S, bisects that big red angle, angle FDM. Okay? Let's take a look at the next section. So it says for numbers 6 through 8, draw a conclusion using the given information and diagram. For now, we'll just write conclusions, and later we'll add in the writing which theorem and definition we used. So here's an example. So if it tells us that ray AB bisects angle CAD, what's our conclusion? So our conclusion is we know that word bisects Our hypothesis, the given information, if this ray is bisecting the angle, then the conclusion is it's dividing it into two congruent parts. And just to make it a little bit easier, I'm going to number those two angles, and I can say conclusion, angle 1 is congruent to angle 2. So that's all we're going to write down is what conclusion, and then we'll come back, or later in the next examples, we'll write down the actual definition. So here in the diagram, we have this triangle with all those vertices. It tells us that H, the given, is that H is the midpoint of segment MT. So this is the part of the diagram that we're focusing in on. If H is the midpoint, then what can we say is true? What conclusion can we make? Well, we know the definition of the midpoint says if a point's a midpoint, then it divides the segment into two congruent parts. So our conclusion is that segment MH is congruent to segment HT. Again, make sure you're naming all of your segments with the segment symbols. You're using the congruency symbol, and you're marking the diagram. It's so important to mark your diagram. Let's try number 7. The given information is that angle HAT, so starting at H, going to A, ending at T, this angle, HAT, is congruent to angle TAM. So the given information is that these two angles are congruent. If we know that two angles are congruent, then what else can we say is true about the diagram? Well, if we have two small angles that are congruent, then that means the big angle is being bisected. So we can say ray AT bisects that big angle MAH. Again, using that definition of an angle bisector. All right, number 8. Given the measure of angle PQS, so I'm looking at my diagram, angle PQS, the measure is 90 degrees. Well, what do I know about angles that have a measure of 90 degrees? What can I conclude about that? Well, there's a couple of conclusions we can make here. If we know that that angle measure is 90, then we can say angle PQS is a right angle, right? We can put that little box there. Well, looking at this again, we can see we have another conclusion here. If this is a right angle, then that means these two segments that form the right angle, we can say that they're perpendicular. So we can say PQ is perpendicular to RS. We can make a couple conclusions here. All right, so we can, again, using all the definitions that we've been learning, we can make a bunch of conclusions. Here are 2 more properties that are really important that'll help us make new conclusions. This one that we're going to talk about today is the transitive property. So the transitive property says if segments are congruent to the same segment, then those segments are congruent. And you can use the same property for angles. If angles are congruent to the same angle, then the angles are congruent. So it's kind of like this train of congruencies. That's how I like to think about it. It's a train of congruencies. And when you have this train of congruencies that all line up, then the first is congruent to the last. For example, if angle A, this angle here, is congruent to angle T, and angle M is congruent to angle T. Look at how they all have the same markings here. If they all have the same markings, then we can say the first, angle A, is congruent to the last, angle M, using the transitive property. We can say angle A is congruent to angle M. We can see it in the diagram, but we can also see it in the given. If I were to rewrite this as angle A is congruent to angle T, what if I just switch these? We can switch the order of this list here. We can say angle T is congruent to angle M. Do you see how these guys match up in the middle? They kind of like connect each other like cars of a train. If these two match, then the conclusion we can say using the transitive property is that the first is congruent to the last. Okay, that's the transitive property. So we see it in that example. Take a look at the second example. This says, given segment DE is congruent to segment FG. So we mark them the same. The next given says FG, the segment that has one tick mark already, is congruent to EF. So it should have the same tick markings in the diagram as well. By doing that, do you see that all three of these segments have the same markings, so they must all three be congruent. And so our conclusion is writing out a new congruency. We can say that the first that we marked out, DE, is congruent to the last segment that we marked congruent, EF. So we can say segment DE is congruent to segment EF because there's this train of congruencies, the transitive property. Again, we can see it written out like a train here. If we say DE is congruent to FG, and then say that same segment FG right here is congruent to EF. So if these two match, then the conclusion using the transitive is that the first is congruent to the last. It's this train of congruencies, the transitive property. Okay, so I want you to try this last one. Again, if segments are congruent to congruent segments, then the segments are congruent. So find that train of congruencies and see if you can figure out a new pair of angles that are congruent. So you fill in the angles here. Okay, so I have my diagram marked with all the angles that are congruent, and I wrote out my list of givens like a train, matching up the inner ones that are congruent. So B and B were the same, so I put those next to each other. C and C are the same, put those next to each other. By making this train of congruencies, my conclusion is the first angle that I had mentioned is congruent to the last. So now I can say angle A is congruent to angle D. This is a new conclusion that I can make and I can say is true about the diagram. All right, so now we're going to try to use these theorems, definitions, and postulates as justifications or as support when we draw our conclusions, why we're allowed to make the conclusion we are making. So this is how we justify our conclusions, and being able to provide support for your decisions is, something that you're going to have to do in life in general. So this is good practice for that, okay? So what we're going to do is read the given information, find the key word, and think about the definition or the theorem. Then we're going to draw a conclusion about the diagram. So we're going to say what else is true about the diagram, and then this time we're going to actually write out the name and write out the correct conditional statements. That means an if-then form of the theorem and definition. Okay, so if we take a look at number 1, the given information is that E is the midpoint of segment SG. So what do we know about midpoint? When you hear the word midpoint, what do you think of? Well, hopefully you think of that it divides the segment into two congruent parts. Hopefully when you look at your diagram, you put those markings in. Those pink markings are our conclusion. That's something additional we can say is true because of the definition of midpoint. So SE is congruent to EG. What is the name of this definition, theorem, property that we used? Well, it's the definition of a midpoint. And now we need to write it out in if-then form. So this is where we have to be very particular about the order that we're writing. If we scroll up to what we had started with, the definition of a midpoint is here. Notice there are two ways we can write it as a conditional statement, and all it does is it switches the order. So we need to make sure our hypothesis, our if, is what was given to us. So the hypothesis is if a point is a midpoint of a segment, then, and then our conclusion is the conclusion, then it divides the segment into two congruent parts. Notice that what we had written out as our conclusion are two congruent parts. So this is the theorem, the definition that we can fill out. Okay, let's try number 2. Again, the given part is our hypothesis. So we need to think about the perpendicular. This little symbol means perpendicular. So if AB is perpendicular to BC, what do we know about things that are perpendicular? Well, they form a right angle. So we can say angle B is a right angle based on the definition of perpendicular segments. And what is that definition written out in if-then form? Well, we could say the hypothesis is if two lines, and notice I'm being very specific to this problem. Do you guys see these line symbols here? So I'm going to use that. If two lines are perpendicular, then what do they do? Well, then our conclusion is that they form a right angle. All we're doing is putting the given information here together with the conclusion, and these two form our reason. Okay, why don't you try number 3? All right, so let's see how you did. Here we were given that we had a bunch of things that were congruent, noticeably that we had two segments were congruent to the same segment, MO. So since those two segments were congruent to the same segment, those original segments were congruent. This is the transitive property. If segments are congruent to the same segment, then they're congruent. It's a mouthful. So really, most definitions we have to write out in if-then form, but transitive is one where we can just write the name transitive. So from now on, if you need to support your train of congruences, why all these things are congruent, you can simply just say transitive. Okay, I hope that makes sense. We're going to do this last example together in class. There's one theorem that kind of slips by sometimes, so I want to make sure we really hit it. I hope this all makes sense, and thanks for watching. We'll see you tomorrow.